If you place a bucket of ice inside a room as the ice melts, it absorbs heat and lowers the room's temperature. That's the basic principle of cooling, but the process is painfully slow. So you bring in an electric fan and let it blow across the ice. Instantly the air feels cooler, the room more comfortable. Still, constantly replacing the melting ice is troublesome. So you think smarter. What if you used a refrigerant instead of ice? Freon, for instance, is a gas at room temperature, but when stored under high pressure, it turns into a liquid. To make it work, you build a sealed copper tube system filled with Freon, creating a closed loop. As the liquid Freon passes through the indoor section, the pressure drops, it vaporizes, and in doing so, absorbs large amounts of heat, cooling the room. The vaporized Freon then travels through the copper pipe to the outside. That's how the system carries heat away. But how can you keep reusing the same Freon? You add a compressor. When the gaseous Freon enters, it's forcefully compressed, raising its pressure and its temperature to nearly 80 degrees Celsius. To cool it back down, you install a fan beside a coiled copper pipe outside. This forms your condenser. As the hot high-pressure gas passes through, it releases its heat and condenses back into liquid form. The liquid then flows toward the indoor unit again, but it's still too warm to cool the room. So you add an expansion valve inside. When the high-pressure liquid Freon passes through it, the sudden drop in pressure causes a rapid temperature drop, sending icy cold Freon back into the indoor coils, ready to start the cycle again. To spread the cool air evenly, you mount a circular fan near the coils, circulating the chilled air throughout the room. Finally, you connect the indoor and outdoor parts into two coordinated units, one inside, one outside, forming a complete self-contained cooling system. Congratulations, you've just invented the air conditioner.